Welcome to our video today, where we're going to explore how to make a Poisson zero inflation model panel. If you've ever worked with count data, you might have encountered situations where your data has an excessive number of zeros. This can be challenging to deal with using traditional Poisson models, which is why zero inflation models are so useful. In this video, we'll take a closer look at what zero inflation models are, how they work, and most importantly, how you can create a panel model that accounts for these excess zeros. Whether you're working in fields like economics, biology, or social sciences, understanding how to handle count data with zeros is crucial. So let's dive into the world of zero inflation modeling and explore its applications. First, let's understand what makes zero inflation models special. Unlike traditional Poisson regression, which assumes that all zeros are informative, i.e., they come from the same process as the non-zero counts, zero inflation models recognize that some zeros might be different in nature. These models propose that there are two processes at play. One generates only zeros, the zero inflation part, and the other is a regular Poisson process for the count data. To create a zero inflation model panel, we first need to understand our data structure. Typically, you would have a dataset with multiple observations over time or different units of analysis, like countries, individuals, etc. The goal here is not just to estimate the average counts, but also how these counts change over time or vary across your unit. The process involves several key steps. 1. Modeling the count part. This involves using a standard Poisson regression model on your count data, ignoring the zeros for now. You'll be looking at how different predictors affect the mean of your count. 2. Modeling the zero inflation part. Next, you need to model what predicts whether an observation is zero or not. This can involve logistic regression or similar binary outcome models where you're trying to predict the probability that an observation falls into the zero category. 3. Combining the models. Here is where things get a bit more complex. And you'll integrate your count and zero inflation models in such a way that you're accounting for both processes simultaneously. This might involve using specialized software packages or functions that allow you to specify both parts of the model together. 4. Panel aspect. The final step is to incorporate how these patterns change over time or vary across different units. This could mean adding time-specific effects, unit-specific intercepts, or even random slopes for certain predictors. The key here is understanding your data and applying the right statistical tools to uncover meaningful insights without getting lost in the complexities of zero inflation modeling. So, what should you remember from this video first? Traditional Poisson models might not be enough when dealing with count data that has a lot of zeros. Zero inflation models offer a solution by distinguishing between different types of zeros and regular counts. Well, creating a panel model involves understanding your data's time or unit structure and applying the right statistical techniques to both the count and zero inflation part. That concludes our video on making a Poisson zero inflation model panel. If you found this helpful, please give it a thumbs up and consider subscribing for more content on statistics and data analysis. Have any questions about how to apply zero inflation models in your own work? Ask them in the comments below. We'd love to engage with you further on this topic. Thanks for watching.